Hey everybody, Dr. A here, and in this video we're going to be providing some background information on soil classification and the most common systems that we use in order to classify a soil. So let's go ahead and get started. So we already have written here, soil classification systems provide a common language to express soil characteristics without detailed descriptions. Classification systems are based on soil grain size and or plasticity properties, okay? Now, when we want to classify a soil, there are several different soil classification systems, but there are three that are most common. Now, the one that you're going to use is going to depend on the project that you're dealing with. So you might have to just use one soil classification system whenever you want to classify a soil, or you might have to use more than one system. It just depends on what that particular project entails, okay? So one common soil classification system is from the American Association of State Highway Officials, or AASHTO. So if you're classifying a soil that deals with a roadway design, you're more than likely going to be using the AASHTO classification system, okay? Now, a second very common soil classification system is called the Unified Soil Classification System, or USCS. This one is used for a wide variety of projects and sometimes even roadway projects. So if you're, dealing with a slope stability problem or a foundation problem for a building, pretty much, it's multi-use, multi-type project usage for USCS. And then, more specifically, if you're dealing with roadways, again, you'll probably have to use AASHTO. Now, the third common type of soil classification system is from the United States Department of Agriculture, so we call it the USDA system, okay? Now, the USDA system is commonly used for agricultural applications or farming-related applications where you need to classify a soil for an ag or a farming type of project, all right? So we're going to go through the background information of each one of these in this video. We're not going to do an example in this video, but we're going to give you some background information and a little bit of how each one of these systems works. So let's go ahead and start with AASHTO, all right? So we're going to write here AASHTO. Now, the AASHTO system was first developed in 1929, all right? And basically how it works is this. Soil is classified into 7 major groups, okay? And these groups have the following designations. They're designated A-1, and they go up to A-7. So the 7 groups are A-1, A-2, all the way up to A-7, all right? Now, how do we further investigate each of these 7 major groups? Well, this is what we do, okay? Groups A1, A2, and A3 are granular materials where 35% or less particles pass the number 200 sieve. All right, so when you have the first thing you want to look at when you're going through the AASHTO classification process is what percentage of particles have passed the number 200 sieve. If you have 35% or less particles past the number 200 sieve, you're going to fall into either groups A1, A2, or A3, all right? Now, what about A4 through 7? A-4 through A-7 are for soils where more than 35% pass the number 200 sieve. Okay, so these are, or we put ... these are mostly silts and clays. Okay, so the A1 through 3 are going to be, you know, your sands and your gravels, and even larger than that. A4 through 7 are your silts and clays, where greater than 35% have passed the number 200. So you have a lot that were caught in the pan after they passed the number 200. All right. Now, how does this work? Well, it's based on the following. Okay, we're going to put another dash here. This is based on the following. So it's based on, as you can imagine, grain size. Well, that makes sense because I just told you, you know, the preliminary thing you look at is, do you have 35% more or less that passes the number 200 sieve? So it's based on grain size, okay? Now, let's go into a little bit of a deeper dive with grain size, all right? When we think of grain size, we want to think about, do we have gravels, sands, and then silts and clays, all right? So for AASHTO, gravel includes materials passing the 75 millimeter sieve, which is about 3 inches, and retained on the number 10. All right. And then the next smaller category is sand. So sands are the materials that are passing the number 10 and retained on the number 200. And then collectively, we're going to have fines, which are silts and clays. And these include the materials that are passing the number 200. Okay, so one of the first things you want to do is get the grain size information and determine what percentages are in each of these categories. What are your percentages of your constituents, your gravels, sands, and your fines? Okay, it's also based on the following. It's also based on, let me change colors here. It's also based on plasticity. All right. When we say it's based on plasticity, we're referring to the plasticity index in particular. Okay. So you may have a silty material if your plasticity index is less than or equal to 10, and then a clayey material if your plasticity index is greater than 11. All right. Now, the other size you want to keep in mind is your cobbles and boulders. Okay, so cobbles and boulders, we'll make another bullet point here. Cobbles and boulders are larger than 75 millimeters, which again is about 3 inches, and are excluded from the sample. But you still want to record the data. All right, so but still record data. So that means if you have cobbles in your soil mixture, you don't want to just toss them out and pretend they never existed. You want to make a note of it, but they're excluded from the percentage calculations that are the process of classifying your soil. Okay. Now there's an accompanying table and or figure that we use to help us classify according to AASHTO. I'm not going to show it here. I'm just going to describe it, and then you can take it upon yourself to look in a properly cited reference to see the actual table or figure. But I'm going to say here the AASHTO classification table is read from left to right, okay? The first group from the left, in which all lab test data falls, is the correct classification. Now this table has, when you read it, there's columns that deal with the grain size properties and the plasticity that we just discussed. So whenever you fall into a column, when you read it from left to right, that satisfies your grain size properties and your plasticity properties together, that is the group that you fall into, okay? So the next thing that we want to talk about with AASHTO is the group index, okay? Or we abbreviate that GI, okay? So we're going to say the group index, or GI, is used for the evaluation of the quality of the soil as a highway subgrade material, okay? And so what we do is we write this number in parentheses next to the group designation. All right. Now, how do we calculate the GI? Well, it's got a nice long equation. We're going to say the GI is calculated as the percent finer than 200 minus 35. And then we're going to open a bracket here, and we're going to say 0.2 plus 0.005 times the liquid limit minus 40, and then close off that bracket, plus 0.01 times F200 minus 15 times the plasticity index minus 10. Okay, now for the sake of like the FE exam, once you get to that point in your career, this equation will be in the NCS FE reference manual, so you don't have to memorize this equation, okay? Now, if the GI is less than 0, then you take it as 0, okay? So if it's a negative number, you set it equal to 0, okay? And then we're going to round the GI to the nearest whole number. All right. The GI has no upper limit, so it could be as big as it gets. Okay. And then for groups A2-6 through A2-7, the GI is only computed using the second term, okay? Which, when we say the second term, we mean this term right here. All right. Now, again, if you don't remember that, that's okay. You can still calculate it through the whole term. It's just this term drops out when you're in groups A, 2, 6, and through A27, all right? So that is our quick summary of the AASHTO method, all right? Now let's talk about the USCS method, all right? We're going to talk about the USCS method next. We're going to scroll on down. Say USCS. This is our second method, okay? This one was first proposed by Casagrande in 1948, all right? It classifies soils into two groups, okay? And those are, I'll make a little star here, sub-bullet point, coarse grain soils. Coarse grain soils. This has less than 50% passing the number 200 sieve. Okay, so these are gravels and sands. Okay, gravels and sands. All right. For coarse grain soils, group symbols start with either G for gravel or S for sand, okay? The second group is fine-grained soils, okay? Here we have greater than or equal to 50% passing the number 200, okay? So 50% or more passes the 200. So these are your silts and your clays, all right? So group symbols starting with M are inorganic silts, and C for inorganic clay, okay? And a group symbol starting with O is for organic silts and clays. All right. If it starts with PT, it's for a peat or muck. Okay, so PT is for peat or muck type of material. Okay. The second symbol, so the USCS is based on typically a two-lettered symbol. Okay, the second symbol, or the second letter designation includes one of the following: W for well graded, P for poorly graded, L for low plasticity, which would be a liquid limit less than 50, H for high plasticity, which would be a liquid limit greater than 50. Okay, so for example, a CL is a low plasticity clay. Okay, inorganic clay, specifically inorganic clay. An ML would be a low plasticity silt. GW will be a well-graded gravel, right? An SW would be a well-graded sand, so on and so forth. So these are the second letter designations that go after the first group letter, okay? So you need to know the following. Similar to AASHTO, what we need to know is, must know grain size and plasticity information, okay? So that summarizes the USCS system. The last system I'm going to quickly summarize for us is the USDA system, USDA, okay? This is very commonly used by agricultural engineers and geologists. It's used for a lot of farming applications, and this is based on textural classification. Okay. Basically what we do is this. We first determine the percent by dry weight of each of the following: coarse fragments, which are for USDA bigger than 2 millimeters, sands, which are between 0.05 and 2 millimeters, silts, which are between 0.002 millimeters and 0.05 millimeters, and clay, which are less than 0.002 millimeters, which would be 2 micrometers. All right. And then the next thing we do is we compute the total weight of the sands plus the silt plus the clay. Now, what does that mean? What we're doing is that we're neglecting or we're excluding the coarse fragments. So we're making a note here. We're going to say exclude coarse fragments, okay? And then what we do after that is convert each weight to a percentage of this total. So what we do is we exclude these coarse fragments and we find the total weight based on sand, silt, and clay, and then we find the percentage of sand out of the total weight of sand plus silt plus clay. So again, we exclude these coarse fragments in these calculations, okay? And then what we do from there is we use this to enter the USDA triangle figure to classify. Okay, and again, I'm not going to show that figure in this video, but this is it's a triangle with 3 sets of axes that you enter in with this information, and then you can classify your soil according to USDA from there. So again, this video is not meant to do a deep dive in any of these 3 classification methods. It's meant to just give you an overview of how each of these generally works, okay? So on your own, or maybe in your soil mechanics course with your professor, you'll should do a deeper dive into the specifics of these and go through some numerical examples using properly referenced materials from AASHTO, USCS, and USDA. The main references I used for this information for this video is information from the Fundamentals of Geotechnical Engineering by Das and Sivakugan, 5th edition, and from the geotechnical engineering textbook by Caduto and Kitch. So hopefully you found this video helpful. If you did, please hit like and subscribe.